Hello, everyone. So let's continue our discussion on accessibility in Android. Okay, so yeah. This image here I have borrowed from a blog post on amdllc.com, which is an accessibility consulting company based out of Baltimore, United States, started by two Indian origin persons. So that can be another motivation slash information for the kind of careers one can have in this field of accessibility. All right, let's take a look at some recommended reading list. As you can see, most of these are coming from the guidelines by Google on Android, material design, and general accessibility guideline. So all these big tech are investing heavily in accessibility and designing tools and softwares for everyone. Okay. All right. So please some background. In the current time, especially after the pandemic, we see that a lot of the things that we are doing have a software services kind of a component associated with it, be it banking, healthcare, entertainment, education, governance. All sort of services have some sort of software associated with those, and because of that, it's even more important that the software that is the software developers or architects, designers of today and tomorrow, the software that we develop is accessible to anyone and everyone. What are some typical barriers to access? The most prominent one is disabilities. So World Health Organization's report of, now this is 10 years old report, to be honest. It says that 1 out of every 7 people in the world have some sort of disability. Okay, and a person with disability may not interact with the software as easily as a non-disabled person. They may have challenges with reading the text. They may have challenges with pressing the appropriate buttons or doing gestures on a touch screen. They may have challenges in hearing any prompt or audio cues, so on and so forth, right? But it's not just about disabilities. Barriers to access can be contextual as well. For example, in a very bright light outside, you cannot read the screen as easily as you would indoors, or you cannot hear sounds. Watching videos is difficult, etc., etc. Age is an important factor, and almost everyone who lives a long life will face that their faculties diminish as they grow older than a certain threshold, and it will become difficult to interact with the softwares that we have relied on for most of our lives. I mean, people of my generation, by the time, say, we turn 70, we will have spent a good 30, 40-ish years using softwares for almost everything in our daily life. And younger people, even more. Okay. And finally, especially in a country like ours, there are barriers due to languages, non-English speakers, and access to technology like high-speed internet, smartphones, etc. So developing accessible softwares is not just for disabled persons, but it's also for this larger spectrum of the society, which includes future you, to be honest, and it's an important business opportunity as well. Okay. So let's see some examples of the services we would use and how they do on the accessibility meter. So here is I'm presenting some screenshots of the Google tool named Lighthouse, which among other parameters gives you a fairly superficial but important check of accessibility as well. So as you can see, it can check for color contrast, images having alt attributes, and links having discernible names, etc., etc. So, fairly straightforward automated check, not a very detailed, deep analysis, but still. Okay, and this is our YONO SBI website. SBI is arguably one of the most popular banks in India, and its accessibility score is 77 out of 100. This is the CoWIN app by the government. I think everyone has to use it at this point in some form or the other, and its accessibility score is 82. And as our guest speaker today pointed out, even our BITS Pilani website is not doing any great, right? So we are only 74. So clearly there is a great opportunity and scope for improvement in this area, even for these day-to-day services. Okay. So as I said, these big techs, especially Google, Facebook, Apple, Microsoft, they are all investing big time into accessible software. One of the recent job ads by Google specified that people with accessibility skills are preferred in their application pool for that particular software engineering job. In addition, governments like United States, in fact, especially United States, have passed several resolutions, made laws to make sure services are accessible. And there are very famous lawsuits in the US where a grocery store chain was sued by a disabled person because their website was not accessible and they had to make changes. In India also, we are seeing a lot of positive change, as we heard from Advocate Varun Jikar earlier today. So while this is happening, then what is the problem? Right? Why don't we see a lot of accessible software out there? And one of the important reasons is computer science graduates coming out of universities have little to no knowledge on how to develop accessible software. Okay. I'll quote from two recent publications. This is a survey of tech industry leaders in 2018, and they found that over 60% of the tech industry leaders they surveyed said that they find it difficult or very difficult to get candidates with accessibility skills. While on the other hand, this paper by a group of researchers reports that limited knowledge in universities results in lack of preparedness for software professionals when they go to the industry and they are asked to do some accessibility implementation. Okay, so there is this sort of a circular dependency, and my research area is on teaching accessibility in computer science, and it focuses on this. So my approach is to solve this aspect of the problem by teaching accessibility skills in software development to computer science students in their college. So in this particular course, software for portable devices, which focuses on Android, we will learn about Android accessibility tools and techniques and testing methods and so on. Okay, so that's the background here. In this first installment of accessibility related lecture videos, what we'll do is we'll focus on some common accessibility concepts. The most common ones are color contrasts and having sufficiently large interactive elements like buttons to click and meaningful labels. So we'll look at these in this video, and then in the next video we'll see some tools like TalkBack on Android and VoiceOver on iOS, which help people with disabilities run essentially a screen reader on their devices and how they can interact with it. I'm going to ask you to do that experiment yourself and get a feel of how difficult it is to operate devices with these services. Using these services, because if you have to. And then we'll talk about Accessibility Scanner, which is an Android tool by Google, which does an analysis of the app under use and gives you suggestions in the form of some changes you should make to make it more accessible, right? So that's the plan. Okay, So let's look at color contrast. So color contrast is defined as the difference between the perceived brightness between the color of the text and the color of the background behind the text. For example, here you can say on this slide, the main text is in dark blue or black, some hue of black and dark blue, in fact, and the background is light beige. Okay, and so it's a good color contrast. But well, what is good? What is the measure for evaluating good? So let me actually show an image from Android Developer Guide with the left text is a bad contrast and the one on the right is a good color contrast. Okay, so I use glasses for my eyesight, and if I remove my glasses, I don't think my video is on, but I'm removing my glasses, and at a distance of about 3 feet from the screen, I cannot make out the text on the left, whereas I can still see some text, although blurred, on the right. So I can make out the capital T and the small e, for example. Okay, but yeah, so color contrast is important. Okay, so coming to what is a good? Is there a absolute measure, deterministic measure? And the answer is yes. So here is the formula. If your text is regular, that is not bold, so a regular font with a size less than 18 points, then the color contrast should be 4.5 to 1. If it is not, then, well, is it bold and is the size less than 14? If yes, then again, it should be at least 4.5 to 1. Otherwise, for all other cases, that is, bigger text than these 2 points with those conditions. So regular text 18 points or more, or bold text 14 points or more, the color contrast can be little lower, but not less than 3.0 to 1. Now, what do these numbers mean? 4.5 to 1 and 3.0 to 1. And who defined those? So these are recommended by the World Wide Web Consortium, W3C. You can go to this link on the slide and see a detailed page on this particular topic. The contrast is defined by a formula which essentially computes the brightness or luminance of the two colors and then takes a ratio of the lighter one to the darker one. Okay, I'll leave that formula, how it is computed and why this particular number as an exercise for you, for those who are interested. And just follow this link and you'll find enough information from that. Some may have a question, that different fonts have different like visible size for 14 point, 18 points, etc. And bold can also be different. But W3C says that although that is true, but this formula works for most cases unless your font is very thin or it's a very unusual font. So for most of the fonts that you will use on the web or Android and iOS apps, this formula works. So as a developer, you should always make sure you can do this. Good news, accessibility scanner or other tools like color contrast ratio calculator, again, follow this link to see more details. They can check these ratios for you. So this tool, for example, you can input the hexadecimal RGB values and it will tell you what is the ratio. Accessibility scanner does it even easier for the Android apps. All right. Okay, so this is the first of the common challenges. The second one is size of the interactive UI elements. Persons with certain disabilities find it very difficult to interact with buttons or other UI elements like the slider to increase volume, etc. if the buttons are very small. Say someone with arthritis or someone with low control over their fingers, or not so good hand-eye coordination, or even someone who has suffered a shock and has tremors in their hand will have difficulty in clicking very small buttons. So you should take care that your UI has buttons that are not very small. Again, the question is, what is very small? Is there absolute measure? And the answer is yes, there is. Okay. So first, let's understand one small aspect of the UI design, particularly in case of Android. So here we see a button. So this shaded area, shaded square, has the dimension 48 by 48 dps. What's a dp? Dp is a measure of device independent pixel densities. So no matter how big or small your screen is, you can specify your element in terms of these dps. Okay. So yeah, the shaded square is 48 by 48, whereas the actual icon for the search button, the magnifying glass, is 24 by 24. Now, if you leave it at 24 by 24, that's very small. But you don't want your magnifying glass to look very big. So what you do is specify what's called padding on this particular UI element. So the padding here makes the overall touchable, clickable area 48 by 48. Okay. So even if you want to have a sleek, small icon on your button, let's say, make sure with the padding, the whole touchable element is 48 by 48. Okay. Yeah. So touch target should be 48 by 48 with padding, which means in case of Android, you can specify it using these attributes: Android : padding top plus Android min height plus Android padding bottom. These three together should be 48. And at the same time, similarly this was the vertical one. On the horizontal one, Android padding left plus Android min width plus Android padding right. Both of these should be 48 each. Okay. So again, this is something the accessibility scanner can check for you. Finally, appropriate labels. So labels are important because your screen readers can read the labels. If we go back to the previous slide, the magnifying glass, if it does not have a label, then someone using a screen reader will not understand what it means. So you should provide label for that. Let's say, search. So the screen reader will say something like search button, double tap to activate search button. Okay. And in such cases, we need appropriate labels. So labels can be specified in Android using the Android : content description attribute in the layout XML file. Some best practices: don't include the UI element type. Like if it's a button, you don't have to say button, because the screen readers like TalkBack, they tell the user that it's a button. So if you specify button in the content description, then it becomes redundant and sometimes even confusing. Secondly, these descriptions should be unique. Even if you are, say, describing a list of similar items, but each of them should be unique. Otherwise, someone who cannot see the screen, who is relying only on the screen reader reading out the description of each element, will not understand or will get confused about where the focus is currently. And finally, if a UI element is for decorative purposes only, like, if it's used to create some white space or shows some design, etc., then set this attribute to the string at null, so that your screen reader skips that. You don't want to bombard your users with all the elements if they are not clickable or if they don't show any useful information. All right. Now, what do you think, guys? We saw the previous two can be checked by accessibility scanner, but what about this? So take a second to think about whether that accessibility scanner can capture this for you. Okay, so the answer is, well, presence of a label can be checked with the accessibility scanner. As you can imagine, it will simply check whether content description attribute is set to a string, right? What it cannot check is whether it's an appropriate label. For example, that search button we saw, it could say button, or it could say magnifying glass. And tools like Accessibility Scanner will say, okay, you have a label for this. But whether it's a meaningful label needs to be checked manually. And that can be done. One of the ways that can be done is through the screen reader apps and manual checking of your app through such tools. All right. So we'll stop this video here and come back with a demonstration of TalkBack and then Accessibility Scanner. Thank you.